spoiler. Okay. Hi, everyone. First of all, let me tell you, it's crazy to be here for me. I mean, Martin just opened this conference this morning, so what the hell am I doing here? But anyway, so who are we? I'm Gabriele. He's Andrea. We work at Buildo, a company that we founded together with a few guys that you might find in the audience. What do we do? Part of the story is that we do help startups in developing their ideas. So we help them executing on their vision in the sense that they come to us with an idea, vision, and something that they want to achieve. And we provide the technical knowledge, the technical skills that they need, that they don't have, to build this product. So we believe in a few things. First one is sustainability. I'll just go very quickly. Sustainability in the sense that we help them make a business that actually makes money, that can sustain themselves. Fairness in the sense that we actually partner with this company. We become a company together. So we build relationships on trust and total transparency and fairness. And finally, which is the interesting point to me, quality. We really love quality. And no, I skipped a slide. We really love quality. We are all engineers. The 6 founders are all computer engineers. So we really want to make products that last in the time, that we can be proud of, and we can basically maintain and reproduce. So taking a step back, I just want to tell you a little story about how we became using Scala. And then we would go technical and we see some part of our stack. So back in the day, was galaxy far, far away, it's Milan, not so far. And long time ago is actually 2013, so again, not so much time ago. A wild, scary large project appears. What does it mean by that? Basically, it's a large project because it is our first client. So it's a big software company that does software for sustaining and managing all the information that goes through a laboratory in hospitals. So basically, it handles clinical data of patients. And it's super large because it's been written in the 90s. And what we've been asked to do is a complete rewrite of the whole thing. This is quite unsettling, especially if you consider the context that we are a 24-year-old young company, just born, first client, boom, complete rewrite of 20-year-old software. So quite scary. So just a little flashback again. Who are we at that time? So Andrea is going to talk a bit about himself.
Hi, everyone. I'm Andrea. At the time, was just fresh out of a couple of internships, one at Google and one at MongoDB, and I did some freelancing on the side at some point. At the time, I was by trade a C++ programmer, and I loved Python, even though I didn't use it much in my real job, or real jobs, I should say. I had some experience with Java, but just university. And what's more important for this talk is a few times during the previous years, I tried to get into Haskell because it felt interesting, it felt something different. And I read on the internet it was cool and it could change the way I programmed. So I tried to learn Haskell a few times and failed most of those times. So I got to the point where I could do some stuff, but nothing that was really enough to build a real project on top of it. And I should mention Real World Haskell is an amazing book. It was mentioned by Phil Casado this morning, and that was my way to get into some real Haskell. However, Haskell was important because it was a gateway drug to Scala. I learned about Scala and I said, okay, I can probably build something useful with that. And that was my approach into Scala. At the time we started working on this large project, however, I didn't have any real-world experience in Scala.
So, to myself, I was a startupper, whatever that means at that time, and a freelance developer. Mostly an iOS developer, actually, for 5 years or so. I basically started with Objective-C, which is weird to most of you probably, but I loved it and I liked it. And first time I actually saw Lambda was in Objective-C, it was a block, and that was quite confusing. I was still confused at that time. I mean, you're passing code, what does it mean? But anyway, in university I got intrigued by Haskell, and of course I didn't get much at that time, but I got there was something to get, let's say. And then I got into Scala with Martin's online course, and I was like, this is pretty much like Haskell in some sense, but I get it. So it was a good experience with it. So the rest of the pack, these are the 4 guys that we co-founded Buildo with. Some of them are here, so you can say hi. And especially if you see the guy in the top left, Daniela, which is there. And so we were doing something together before this. We were doing a startup, of course. And it was about hosting and serving videos. And it was pretty much a year of work, countless factors, as you can see, because the requirements were changing all the time. And I mean, when you work with a brilliant designer, you also get new requirements basically every day. And it was in Node.js. I don't have anything against Node.js. I still use it today. But if you do a very large project with complicated logic, it was a mess for us, at least. So if you ever done something like this, I'm sorry. I mean, I don't know, maybe you have great experience with that, but we didn't at that time. So to go back on track, this is our scary project, and we want to set up some requirements because we need to pick a technology. And spoiler, we got Scala, of course. But why? Mostly because we wanted type safety after coming from Node.js. Every time you refactor something, you forget a variable. And that's quite boring, and it's quite annoying to go through the code and to check that you did everything right. Even if you unit test, sometimes you forget something. So we want a type system anyway. Concerning expressiveness, what I mean by that is that we already knew that the code base was going to be huge. It was 20-year-old software that does a lot of things. We don't want an unexpressive language as Java, for instance. Again, I don't have anything against Java, but the code size gets pretty big. So we want something expressive and we want something safe. And the combination of the two doesn't really get you a large choice. And concerning flexibility, we have two requirements by that. So the first one is that we need something flexible enough to get dirty sometimes, because we are basically maintaining legacy software. So especially when you deal with databases, this is Oracle underneath this, you want the gateway to go to Scala, to Java, or to some other implementation. You want mutability sometimes. So you definitely want that. Even if at the time we didn't have a clear case in mind, we knew we wanted that. And another kind of flexibility we want is to be able to abstract away concepts from the language, because we already knew this project was going to be handed over to some other developers that need to maintain these over the years. This is happening right now. And we want a language which is flexible enough to make complicated infrastructures and abstract the complexity on the language, and to build something that is usable by and understandable by other developers. So Scala was a natural fit at that time because, I mean, if you read the instructions of Scala, it's pretty much all of these things. So we went with that. We had a great experience with it for the few ones that we had at that time. So that was our choice. So fast forward to today. This was the whole story of how we became on Scala. But what do we do today? We do startups, right? And you don't do startups on Scala, do you? I mean, you use something else. You use Rails, you use Node, you use PHP. And actually, if you take a look at graphs, I don't know what you can read from this, but this is like a distribution of technology on different startups. And basically, you get JavaScript, of course, Ruby on Rails, PHP, Java, Python, Django, and then only then you get some Scala, Clojure, Haskell, some Go, Perl. This is 2014. At that time, it was 2013. So there was even a much higher spread. And so people don't use Scala for startup, not much at least. And also the perception about the language is, do you know Scala? Yeah, is that thing that Twitter uses, right? Is that thing that Twitter uses to make complex systems, to make huge infrastructure, right? It must be complicated because Twitter uses it to do complicated things. I mean, probably it's not true today. This perception is not as much as convinced on this as before, but at that time, Twitter Scala was pretty much a one-to-one thing. And again, other perceptions that you have, developing in Scala is low, you need to learn, you need to trick the compiler to get things done, and the learning curve is steep. Ultimately, is it worth to do something like this? We think it is, but we see why in a second. So what we did was actually doing the opposite of what most people happen to do. Yeah.
I think you forgot one thing. Most of the people just say it's very hard to find Scala developer. It's not something that happens.
I didn't forget. I left it out. We're going to talk about something like that later. But that's an excellent point. I was meant to leave it as an elephant in the room and talk about that later, but you got me. Okay. Thank you. So we started with a big project, and we scaled it down, which is something that usually, you don't happen to do very much. You usually scale up. So we wanted to see whether we could keep our stack that we made for the big project and to take it down to startups. So we tried to do so, and why? Well, we liked it. we liked Scala. That was a great experience with the first project, and it was a big project. It's still going on today, by the way. And most importantly, we were a small team. We're still a small team. We were 6 people at that time. We're 11 people now. But if you take 6 engineers and you start making them spread technologies and learn different things, what you get is a very uncohesive team. You basically accumulate depth in technologies. You want to keep the team focused on a single technology or a single stack of technologies. That was a requirement. And finally, we don't do a startup concerning the is it worth it to learn it. We do startups. We want to have a model that we can basically replicate and reproduce with confidence. So we want something that can last and that we can use in our job, which is making startups. Again, it's not silent yes. So why do we like it? This is more perception. It's from experience. We don't have real numbers. So even though we're doing research on this, we're actually doing a comparison between languages, and we will probably publish the result in a few weeks about this. So it takes more time to ship code, but it takes less time to ship code that works. What I mean by that? But usually, when we were doing especially the Node.js thing, it's very easy to hack something that works, that appears to be working, and then you spend a lot of time debugging. So you have this time span in which you ship something, and then you spend a lot of time debugging, which is very scattered around time, in the time. So what we found out when we moved to Scala is that it typically is like if it compiles it's working thing. But of course it's not, but most of the time you get it right. Or if you get it wrong, you can fix it in a less time than with the usual approaches. Other things, intrinsic correctness and clarity. By that I mean that you have a type system, basically. So a whole class of bugs is taken away. Just typos, forget about that. You don't get stupid mistakes. And clarity, I would swap the two, actually. I should have. Clarity is the most important thing. So you get a code base that is well documented intrinsically because you can read the types. That's a very good thing. It's often underestimated, but it's really good if you pass it over and another developer can read the code and see the types and have a clear idea, or at least the semantics locally of the methods, which is a good thing. It's easy to write testable code. If you embrace the approach that Scala tries to teach you, you embrace a modular and functional approach. You write tests very easily because you have pure functions, and if you do things properly, and it's easy to do things properly, you have testable code. And even if you don't test anything, even if you don't test all of the things, you can still refactor with some confidence, and you won't have stupid mistakes. So there is a trade-off. If you're in a rush and you don't write a test, you can still have some kind of confidence that it's not totally wrong what you've done. Finally, the JVM is a nice environment. It's often demonized in a way, but it's a great environment if you need to do deployment, and it's a great environment if you need interoperability with other languages. There is a whole class of libraries which is available for Java, not script. We also do JavaScript, but it's not the case. For Java, and so that's useful, especially if you maintain legacy software. So it's a famous quote from Martin Ondesky from this morning. So Scala trusts the programmer to do the right thing. So again, Phil, this morning, said something like this. It's not verbatim. We don't have enough material. So actually, I really like Scala as a language, mostly because it doesn't force you to do things. There is not a scholarly way to do things. But it puts you in a situation in which you don't know what to do sometimes. So you don't have clear ideas on what you're actually supposed to be doing. You have a problem, and there is no the way to fix it, to tackle the problem. So what we want to do today is actually to give some material and to give you our experience to some extent, to go behind the scenes and to show you some specific problems that we had to deal with and how we try to solve it. And then we're going to talk about some open problems that we have. So we're going to talk about dealing with a diverse and evolving set of requirements, which is something that you happen to be doing a lot with startups. And we're going to talk about Akka, and it's a little bit generic. We're not going to talk about Akka as a framework. We're going to talk where it is placed in the architecture, let's say. We're going to talk about controllers, so we see how they fit in our platform, and then some open problems, both technical and about people, and you already mentioned one. So I'm going to pass it over to Andrea.
Great.
So you can use yours or mine.
Thank you. So let's talk about how we deal with a large diverse set of requirements. So you probably, every one of you is working on a project. Everyone of you is probably working on a project where the set of requirements is changing a lot. And that's something that's really typical of our industry. And when we do startups, then the rate of that change is crazy. And what's even worse for us, or what makes it fun for us, I guess, is that we don't do one single startup. We have multiple startups. At some point, we had more startups than engineers in the team. So, and we are like at 10 startups and 11 engineers at this point, I guess. And so how do we do this without going insane? And our approach is to use a really well componentized infrastructure. We call it a mix and match infrastructure. And what it means is we have a set of components to do various things, and we pick and choose the ones that we need for each startup, depending on the set of requirements of the particular startups. So this is a general example of what some of these components are, some that don't really matter in this context. And what we do is, for example, we start with a small startup that doesn't have a large set of requirements. It's pretty simple, just have to serve requests. We have an API, for example. So we choose, I don't know, Spray to deal with HTTP requests and to do the routing of the request to our business logic. Then we can use Akka and Slick to access the database. Then some startups, and we hope some of the ones that we do will happen to do this, grow. And they might need more. They might need more the challenges to work with them increase, and we need more stuff to be able to cope with those new requirements. And so we had some stuff. We had a few components to get what we want. Then, as we mentioned, we also work. Part of our business model involves doing more of consulting jobs. So we have to work, and we enjoy working with larger, more complex projects. And in that case, we need even something more. In this case, the example is adding Elasticsearch for search. So this is the idea. It's how we deal with this kind of insanity. And what's really natural to do in Scala for this kind of problem is to use a cake pattern. So we have a bunch of components. We want to combine them together in various ways for the different startups. And remember, these aren't startups. These aren't microservices. These are completely separate startups that do different things. So what we do is, the cake pattern works like this. You define your modules as abstract interfaces, the wireframe bricks here, and then you can define a concrete implementation for each one of your components. And you can definitely define multiple concrete implementation in the same code base. For example, we can have a data access layer or data abstraction layer implemented both on top of MySQL and on top of MongoDB, for example, for a single project. And what's great about the cake pattern, you can then decide at the time you build the artifact, the app that you want to deploy, to pick the components that you want. And the compiler is going to check that you filled in all the blanks. So all the abstract methods that you left around, the compiler is going to tell you if you've forgotten anything. So we just compose them together and get the app. This works for example, building the production environment or the staging or canary environment, or building smaller sets of component together and mock out others to do testing. So how does that look in code? Just a quick look. This is a simple example of what the abstract interface of a user service might look like. We have a login method that lets a user log in with username and password. If it's valid, you're going to get a token back. That interface to be implemented might require talking to a database. Actually, would definitely require talking to a database. And so we describe the database module in such a way. So we have a trait that has the functions required to implement that. That's not the actual semantics, and the implementation is not really important. Let's just have a look at what it looks like to implement, for example, the data module. So you extend the trait, and we're using self-typing here, but it's not strictly required for this kind of approach. And then we provide an implementation. This is really stupid. It's just in memory. But it's just for illustration purposes. And then we would do the same thing for the other component, the actual app user service. And once we have both concrete implementations, then we can merge them together just using inheritance, just combining the traits together, and we get the entire app. And the compiler is going to be happy only if we have filled in all the blanks. So if you have provided a concrete implementation of all the traits. And then you can just use app as to call function on it, and it's going to work beautifully. What's great about this kind of approach is first testability, as I mentioned before, but also it forces us to have clear, defined boundaries between the layers of our applications. So if we need to, for example, swap out a database because the startup is growing and it needs to scale, then it's much easier because we have clearly defined where the controller or the business logic stops and the data layer starts. And this is like huge scale. Let's hope we're going to get somewhere like there at some point. And so you might be wondering, aren't you guys building, well, typically startups build web APIs, right? And typically the approach is to use a framework. In Scala, you will probably use Blade. And we aren't really fond of frameworks because our experience is that frameworks, even for relatively simple projects, are great if you want to build something that whose requirements are exactly or similar to what the framework author thought about when he was designing or she was designing the framework. However, if you start to have a single feature that you want to implement that was not considered, then it gets a mess. You start having to fight the framework to implement it. So we say, no, thanks. We are not going to use frameworks. We are just going to build a wrap out of various components. We mesh them together, and then we get our system out of that. And that actually does work. What's interesting here is some of the components are taken from the open source community. Some are pre-built, are vendor APIs, for example. Some we build our own, even if there's something already available somewhere that would do the same thing. And the reason why we do that is to obtain exactly what we wanted in terms of functionality. So if you do it yourself, you know exactly how it's going to behave. And over a year and a half of working on this stuff, it's probably taken us less than 3 weeks to develop our internal components for like logging and configuration. So it's not a huge undertaking. They're usually pretty simple to do. One last piece to how we deal with diverse components is to leverage the type system to have a clear checked interface with the outside world. So if your front-end team is using JavaScript, you're not guaranteed that their API calls are always going to be exactly the way you expect them. Actually, typically, they're going to be sometimes really crazy and they make no sense. And if you fit something like that into a node server, it's going to break somewhere down in your business logic because the router or the layer that accepts the request doesn't check that it makes sense. So what we use is Spray Router, which is a great DSL to express what kind of request we can deal with and the types of all the parameters to it. So this example here is we accept a request to confirm a consultation that that a patient might want to book with a doctor, and the ID of the consultation they want to confirm is passed and is type checked. So that's how we deal with diversity requirements when we have a bunch of startups that evolve all the time. Use a cake pattern, we use testing, and the cake pattern helps a lot. And type safety is amazing, both to check that your interface with the word is respected, and to be more confident when you push on a Friday night because you have a release on a Monday, or more typically you push on a Sunday night when you have a release on a Monday at 7 a.m. So yeah, that's it for this part. Let's talk about akka or not akka.
Okay, so the akka part actually is a mistake that we made. Not akka. Akka is good. We actually made a mistake starting using it, and I just want to share the experience. So if anybody is going to face the same issue or feel awkward about something, it's probably something that happened to other people before. I'm just here to testify. So whenever you start using Scala, you start looking around and you start looking for frameworks, libraries, the ecosystem in general. The first thing that gets pretty much in your face is akka. Everything is based on akka. Everybody talks about akka. TypeSafe talks a lot about akka. They have good reasons for that. It's a great framework. So step back. We're actually building APIs, and we want to be reactive, whatever that means. So we want API that don't block. They don't block a thread. They actually quite responsive. So Akka, it's a natural fit, right? It's good to have actors because you can handle separate requests with actors, and you don't block a whole thread, but you leave the actor system to manage the details. And it's great, and Spray Router, for instance, does that. It serves each HTTP request on different actors. So you start thinking, okay, we have layers, as we saw before. We have controllers, we have the router on top, then we have the data layers, and we have some other layers. We need to communicate between these layers because we don't want to pass, I don't know, the HTTP request, for instance, down the whole cake because we want to keep the levels actually separated. So what do? We started using, we can use Akka, right? We can use actors to do that. So you start looking at the tell pattern in Akka, which is basically you tell something and you don't expect a response back. You just fire and hope that somebody will eventually get to you. Which turns out is quite awkward if you need to do a service like this, which you typically handle a request, you go on the database and you go back. You actually want to go back. You want to be sure you go back and you handle the whole thing. So you start looking at Akka ask pattern where you actually ask for something and you wait for it. And then you realize that's actually a future. So how about we just use a future? So this was the whole story. It took us a while to figure that out. It's probably a rookie mistake. And we were rookies at that time, probably even now. So I just wanted to share with you the experience of doing that. So if you feel awkward using Akka because you feel like you have to because everybody's using it, maybe you're using it in the wrong place. But there is a right place to use it. And again, this is our architecture in a nutshell. So we have a router, we have controllers, we have data modules. We talk across layers with futures, usually, with just plain method interfaces. And then if you need to do something like notifications, or what we do also is feeding an Elasticsearch index to keep it in sync, you can actually leverage Akka a lot, and it works great. And it's what you're supposed to do, to have a potentially distributed infrastructure and to perform some async job. And it's awesome. It works really well. So again, this was a point, like, don't do the same mistake. And if you do, you're not weird. You're just doing something that we did already. Use Akka for dispatching requests in Spray, but then within the single request, we just use features because it works. And Akka is great for async tasks, like notifications and Elasticsearch updates or whatever you have the need to do. So back to you.
So you saw in the diagram before, we have a controller layer. That layer is what deals with the business logic. We have the router layer on top that accepts the requests. I'm going to show you like exactly the same what I was showing you before. This is the routing. And then we want to call into the controller to perform the action. I'm going to talk about 1 second of how the interface between the controller and the router is. We really wanted to avoid polluting the controllers with any HTTP concepts. So if we realize that HTTP was the wrong idea, or even just to keep the logic clean, we wanted to make sure that what's returned by our controller is something that doesn't have anything to do with HTTP necessarily. And our representation for that is controller response. It's wrapped in a future, as we talked about. And this is how it's defined. So controller response is an algebraic data type, or a tagged union. It has two possible values, which are either OK or user error. So OK is everything went right, and user error if the request that we were asked to process doesn't make any sense because the user has provided invalid input. And the kinds of errors that are possible are the ones listed there: not found, invalid operation, or forbidden. And so this is great. This is the separation between our two layers. It works great, and we have some glue in the Spray router. Spray JSON is amazing to convert this stuff into something that can be served over the wire without having to do anything boilerplatey. So you see that there's nothing telling Spray how to convert this to JSON here. It's just magic, pretty much. And however, let's look at what it means to implement a controller this way. So we are trying to confirm a consultation that a patient might want to book with a doctor. And what we want to do, the small box at the bottom in Phil's talk this morning, the actual action is just to update the status of that confirmation, consultation to confirmed. However, we want to check some stuff, namely that the user is in fact a patient, that the consultation exists, that the consultation actually belongs to that user and not somebody else. And so you can see this is the result of trying to get that logic and factor it out from different controllers that do similar stuff. And we end up with continuation passing style. If you've ever done JavaScript, this is what's called callback hell. So, and this is it is a reasonably decent looking method. We had much worse. So we started to look at this and, hey, this doesn't make sense. There should be a better way. And the way we got to a better way is start and realize that controller response is in fact an either. So it's either okay and user error, or user error. And in particular, we were starting to get into Scala and yes, we are nuts. We also use Scala in startups. And so this is clearly better represented as either a controller error or an A, which is the result. I'm sorry, this is the only way I can actually explain the difference between either in Scala Z or in the proper Scala. Somebody call it disjunction. The controller error is represented in a in the same way it was represented before, so invalid operation, etc. And then we realize, okay, we have this, which is a monad. And then we wrap this in a future, which is a monad. So we have to combine those. Otherwise, we are not going to be able to do any control flow or any composition of those. And so we use monad transformers to do that. I'm not going to get into what that means. The point here is when you have that type definition up there and you try and refactor those methods that you saw before, you get this, which is not entirely beautiful and imperative looking, but it's much better than it was before. And it's much easier for us to compose those and to write a function that to do a check just returns a future controller flow and combine those. What's really interesting, however, is that me and Gabriele set this up, and we are somewhat familiar with Scala Z. We probably would say that we kind of understand what a monad is, and so we managed to get this done. However, Daniele, who we mentioned before, is not familiar with Scala Z pretty much at all, and he was tasked with converting a large part of our application to this style from the previous one. And it worked. So you don't need somebody who knows exactly the concept as long as you have set up the infrastructure right. So as long as your types make sense and your infrastructure makes sense, you can just bang at the compiler until it says, okay, yeah, that makes sense, that's fine. You just have to fit the right type in the right place. So how do we deal with that? Complex control logic, monads. And the important point, they are non-trivial to design sometimes, these kind of architectures, but they're definitely much more straightforward to use. And with that, I'm going to move on to what we haven't figured out yet. So that's our approach to doing controllers. It's definitely not, maybe not the best one we could come up with. Phil's talk this morning gave us a bunch of ideas, and I'm kind of proud that we got to something that's conceptually somewhat similar, even though there looks much cleaner, I have to say. And the open problems here are the modularity that we deal with, that we use to deal with the diverse set of components comes with a cost, which is boilerplate. You have to define all the interfaces. And also, because you have these clear boundaries between the components, you have to have different representation for the same piece of data in the various layers. And that means that you have to do conversions between those. And that's always somewhat awkward. We are considering shapeless for that, but it's not clear yet what we're going to do or if anything can be done about it. If you have ideas, we'd love to talk to you. It's hard for us right now to trace a request across the components the way we have built the architecture. So we can't know which request generated a particular action on a data model, which is really interesting for performance and for debugging reasons. That's, again, something that you're trying to figure out. If you have ideas, we'd love to talk to you. And I'll give it back to Gabriele for your question. People, how do we have
people? We set up an infrastructure that is quite, I'd say, uncommon. So you may wonder about hireability, because you need to build teams that work with this stuff, basically. So I hope I had like the perfect solution, like, ta-da, it works, it's perfect, that you're going to find people. Actually, it's not so easy. Of course, hireability is an issue because Scala is not so widespread as many other languages, especially in the context of startups. Actually, I'm going to say what you haven't done and what you cannot do. You cannot throw a developer at this. And by this, I mean you cannot just hire a bunch of developers and have them try to make progress on this. Even though it's very easy to work with this infrastructure, if you know some Scala, you still need people with a brain. So, and it's hard to find them, I swear. So you still need people that, even if they don't know Scala, they can actually learn some basic concepts and can do some engineering work. So again, not easy. But there's an upside of this. The team you're going to build in the end is going to be a great team because you hire a bunch of PHP developers. Again, I have nothing against PHP, and PHP is a language that can be used very effectively. Look at Facebook. They build awesome things, and there are awesome engineers that work in PHP. But if basically what you do with Scala is setting the bar high, and you just say, okay, my startup, my company has more technical requirements than usual. And this is going to give you and actually collect and you get actually good people. They come to you. Actually, this happens to us too. We are a startup ourselves. And we saw many good and interesting people come to us because they're intrigued by the fact that simply the fact that we use Scala. So to say it with a quote, this is from Robert Glass from Common Software Programming Principles. And so numbers are made up, of course. I hope he didn't measure that. But you can actually, if you think of, it's a great bargain to get a good developer because it's probably going to do much better, I'm not saying 30, but much better than your average developer that you find on Elance. So again, it's a good bargain. We think so. We think building teams composed by good engineers or good programmers for what it's worth, it's a great way of doing startups, and it's a great way of doing companies in general. So the best companies, especially tech companies, they all have great engineers. You don't take anything. And using Scala, it's a signal that you're doing something like this. So what we do, this is a shameless plug, what we do to get good engineers is actually to try to work with the community. And this is a project that we started this year. And there wasn't a meetup in Milan. I'm talking about Scala specifically. And so we started one because I wanted to go to, and I didn't find one. User story, you find it a meetup because you didn't find one. And this is great because the community in Milan is growing a lot. I mean, we have a meetup tomorrow, and there's going to be 80 people there, hopefully. I mean, they signed up. I don't know where they're going to show up. It's Saturday. And it's great to see the community growing. So this is to give you a hope that we're going in the right direction. People are loving this language and this way of doing things even more than before. And we try to do our part. So this is what we got, apart from a flying fish. Thank you. Any questions?
I think we have around 6 minutes if you have any questions. Yep.
Yes, the fish is real. Yeah.
So I actually didn't get why don't you use play, because like there are already controller compositions, there are already results which you like re-implement yourself,
right?
And you already use some parts of it, so, and it's not so limiting as let's say Java 2E. So
yeah, I definitely agree. I have to say we didn't explore play too much in the beginning, mostly because we hated the fact that you had to specify the routes in a text file, which was not Scala. At least at the time, that was like it was. Unless like I was completely wrong, but I think it was like that. So we hated that, and we did frameworks, and then it was a couple of years ago. I don't know if how play was great. Maybe now play is awesome, and we may have made a wrong choice there. But we are really, really scared to get into a framework. So the answer is, in part, we hated some of it. In part, we hated the concept of frameworks. So we want to understand the entire thing. So if you work with Play, you have the facilities that you mentioned. Not having built them yourself, sometimes, at least my experience with other frameworks, is that you don't really understand all the moving parts, and we can't really afford to not understand the moving parts. We want to know exactly what's going to happen because we have like 9 projects, so it would be insane to have to go inside and deal with something. So yeah, Play framework, definitely great. We do something else.
And actually, on top of it, we don't hate all of it. We use part of it, like a norm, for instance, which is moved out, has been moved out, but it wasn't at that time. We use that for a project. We moved to something.
But yeah, you're right. I mean, but actually now Play is modularizing, so they move out like template engines, they move out persistent, so it will be. It actually becomes like a library, not a framework.
So they kind of agree with us. So it's great. They started to do what we do. Cool.
Do you already have some experience about the handover your projects?
Handing over?
Yeah.
Yeah, there's a guy there, Federico. Hi.
Hello.
So he's been working on our original stack, and he's living proof that you can be still alive after working on this thing. And so yeah, we have some experience, and a few other guys who work on our technology. Even ourselves, in the sense that some of us are completely unrelated to some project, and at some point they get it halfway through. And so we're pretty confident that it takes little time to start working with the stack once you get acquainted with some concepts. So we definitely have some experience, not as much as we would like, but yep.
You definitely need to have somebody with spirit, and maybe most often when we end off, we still are involved somehow in the project. So if they need some help with something that's more conceptual or something in the architecture, we are definitely there to help them. So
yeah, there's some training involved, of course, but we provide that.
So it's not complete handover. So it's not a complete handover.
It is eventually.
It's probably going to be
eventually,
eventually,
in the beginning.
but
You cannot just here's yours. You go ahead. Yeah, it's a training in the beginning. It's a partial handover in the beginning. They start implementing feature basically by copy and pasting, like the whole architecture. For instance, implement this route by taking this as an example, like the full stack route, for instance, new functionality, and then they're able to take over completely.
Any other question?
Anybody else?
And then I guess, thank you very much.
Questo sta questa cosa? Non niente.
Ah, wow.
Che